Hello, everyone, and welcome to another Festive Tech Calendar. My name is Veronika Kolesnikova. I am here in Boston, Massachusetts, and today I am excited to share some knowledge with you about machine learning and specifically about classification. So let's go. Let's talk about classification using Azure Machine Learning Studio. Here you can see my Twitter handle, so if you have questions later on, feel free to follow me there and reach out to me through Twitter. You can also find me on LinkedIn, but please leave a message why you want to connect and how you know me. So now I just want to introduce myself really quick. If you've been following Festive Tech Calendar for a while, you probably know me. I've been recording videos for that great initiative for at least a couple of years. But if that's your first Festive Tech Calendar video, I would like to tell you more about me. I am 4 times Microsoft MVP in AI. Currently, I'm working as a senior software engineer here in Boston, Massachusetts. I used to work mostly with Microsoft technologies like C Sharp, .NET. I love cross-platform solutions with Xamarin and Maui. I am obviously obsessed with artificial intelligence and machine learning. And recently, I also started working more with Java and Node.js. And my hobbies are dancing, traveling, and aerial fitness. And here's the agenda for next probably 50 minutes or so. We'll start with just quick overview of artificial intelligence and machine learning. I'll talk about supervised and unsupervised learning. Then we'll go to next level and talk about specifically classification in machine learning. Then we'll go to specific algorithms that you can use for classification. I will provide a couple of examples there of the algorithms that you can use for all kinds of classification. And then I'll talk about steps for machine learning training that you can use and you understand how you can actually go from that theoretical part to practical part using those steps, and then I'll move to the demo. I'll show you the Azure Machine Learning Studio. I'll show you the portal, provide an overview of what is available there, and then I will specifically show you how you can use Azure Machine Learning Studio for all your classification needs. Let's talk about machine learning and artificial intelligence in general and supervised and unsupervised learning. So, machine learning has so many different definitions, but in general, it's something that we as humans are good at, but machines are not. So, data scientists, machine learning engineers, and even software engineers are trying to mimic human logic using if then rules, decision trees, and other techniques to actually make machines think similar to how we think. There are two main categories in machine learning: supervised and unsupervised. There's also a third category there, reinforcement learning. But today we'll be talking about those two main categories, supervised and unsupervised learning. Here you can see I have a couple of fun pictures. So supervised learning is the process of making an algorithm to learn to map an input to a particular output. That means that the data that you have collected here is labeled, and so you know what input needs to be mapped to what output. And an example there is if you're using the computer vision and you want to customize it, you are uploading the images and then you are labeling them. So you're telling your machine, you're telling your algorithm that those images are dogs and another set of images are cats. And then you are checking if your machine learning model understands correctly and can recognize. And image recognition is only one example there, but I'm just going to use it here for now. So if your machine learning model correctly recognizes dogs and cats, then you can use that machine learning model. Obviously, you might need to tweak it later and update it, add more images if you see that it doesn't perform well anymore. And here you can see an example in school how a teacher can show a picture and then ask a student what's on the picture. Here you see a banana for apples. If it's not correct, then you need to retrain your model. You need to maybe add more data or maybe add more time for your algorithm to actually learn. And then you test it again, you check what is on the picture, and then if it says apples and it's correct, then it's all good. Providing the labeled content, labeled data, and then your algorithm is learning from it. Then you test it. If it acts and responds accordingly, if you are happy with the results, you're using the model. If not, then you are just retraining it basically. So that's supervised learning. Unsupervised learning is when you have the data without any labels and you are unsure about the outputs. So you model your algorithm such that it can understand patterns from the data and output the required answers. And in that case, you actually do not interfere with the algorithm learns. So you don't have that process of checking if the algorithm provides correct information, and then you're using it. If not, then you are training it more, maybe eating data. That's not the case for unsupervised learning. It actually acts completely different. And then again, I just want to remind you that there is the third type of machine learning is reinforcement learning, but we are not going to go there today. I just do recommend you to check it out for yourself if you're really interested in machine learning and want to learn more about the theory for each type of machine learning. And here I want to provide an overview, that bigger picture comparison between supervised and unsupervised learning. For data sets, you have labeled data set for your supervised learning and completely unlabeled data set for unsupervised learning. The methods you're using for supervised learning is guided learning. That means you are always checking if the model is recognizing the objects correctly. And then you are adding more data, retraining it, tweaking it in a way. And then for unsupervised learning, the algorithm learns by itself using dataset. The complexity of supervised learning is simpler than the unsupervised learning. It means that it actually requires more time, it actually requires more compute power, So it depends what kind of data sets you have, what kinds of tasks you are trying to solve with machine learning. Then you need to pick the best option for you, whether it's supervised learning or unsupervised learning. The accuracy, I think it's obvious that supervised learning is more accurate because you are already telling and teaching the algorithm that that object is this and this object is that. You're basically organizing the data in a way which is easier to understand and easier to learn from, and the accuracy is higher for that type of machine learning. And unsupervised learning is less accurate, but again, it doesn't mean that you shouldn't use unsupervised learning. Unsupervised learning is the only approach for a lot of tasks and for data that you have. You might not have that labeled data set, and you might need to use unsupervised learning for your unlabeled data set. Now let's talk specifically about classification in machine learning. Classification is a process of categorizing a given set of data into classes. It can be performed on both structured and unstructured data. The process starts with predicting the class of given data points. The classes are often referred to as target, label, or categories. On that schema here, we see that classification is actually a category of supervised learning. Another category is regression, but we are not going to cover regression today. If you're interested in learning more about it, I do recommend checking it out. There are lots of resources online. In short, classification is a form of pattern recognition. We have binary classification, which is a type of classification with two outcomes. For example, it's either true or false, or like examples I have on this slide, like spam, no spam, cats or dogs, dogs or muffin. We all know those examples. There's also a multi-class classification. It's a classification with more than two classes. In multi-class classification, each sample is assigned to one and only one label or target. So we can recognize maybe cats, dogs, and flowers. That's an example there with multi-class classification. But there are lots of options there. Maybe you want to put objects in different categories. Now, with better understanding of machine learning in general, supervised and unsupervised machine learning, and classification specifically, it's time to move to classification algorithms. There are lots of algorithms available, and people are creating their custom algorithms. Some companies they're investing a lot of money just to improve existing algorithms, implement them using their software. So now I want to talk about probably the most famous of them. I'm just gonna provide a couple of options so you see what is available, and I do recommend to actually go and read more about the algorithms and options that you have for all your classification needs. In machine learning, classification is a supervised learning concept which basically categorizes a set of data into classes. The most common classification problems are speech recognition, face detection, handwriting recognition, document classification, etc. It can be either a binary classification problem or a multi-class problem too. There are a bunch of algorithms, and I'm gonna cover just some of them, so I do recommend to check others as well. And we'll start with the logistic regression. The logistic regression is that algorithm uses one or more independent variables to determine an outcome. In the classic logistic regression, the outcome can only have two possibilities. So it's muffin or dog, yes or no, 0 or 1, and that's a classical logistic regression. The goal of logistic regression is to find a best fitting relationship between the dependent variable and a set of independent variables. It is better than other binary classification algorithms like nearest neighbor since it quantitatively explains the factors leading to classification. There are lots of pros and some cons of using that algorithms. If you want to actually expand it a little bit, there are options for multinomial logistic regression where you can have several possible outcomes. So let's talk a little bit about advantages and disadvantages. Logistic regression is specifically meant for classification. It is useful in understanding how a set of independent variables affect the outcome of the dependent variable. It is really easy to actually um, check those variables. It's easy to be transparent, and because it's easy to be transparent, it's easy to make sure that you are acting responsibly, which is very important. The main disadvantage of the logistic regression algorithm is that it only works when the predicted variable is binary. So that is in classic logistic regression. For multinomial logistic regression, that issue gets eliminated. The main use cases there are identifying risk factors for diseases, word classification, weather prediction, and maybe even voting applications. In order to actually perform logistic regression, you can use Python, you can use lots of libraries that are available out there. Also, most of them are ML tools, probably all of them have logistic regression as part of their suite. So if you are not building your models from scratch and using more automated options, then logistic regression is most likely included there. The next algorithm here is naive Bayes or naive Bayes classifier. It is a classification algorithm based on Bayes' theorem, which gives an assumption of independence among predictors. In simple terms, a naive Bayes classifier assumes that the presence of a particular feature in a class is unrelated to the presence of any other feature. Even if those features depend on each other, for the purposes of that specific algorithm, we assume that they're all independent. There are some advantages and disadvantages of using that specific algorithm. The naive Bayes classifier requires a small amount of training data to estimate the necessary parameters to get the results. It is really good that you don't need to have a lot of data. Sometimes you just don't have that option to collect enough data before you need to go and train your model and create your model. Maybe you just don't have access to huge amount of data, so that algorithm can be perfect for your specific needs in that case. The only disadvantage is that they are known to be a bad estimator. There are some use cases that are most popular and they're better with naive-based algorithm. Those use cases are disease predictions, document classification, spam filters, and sentiment analysis. So if you want to learn more about the formulas and how the theorem is actually working and what the theorem entails, I do recommend to check it online. I'm not going to go too deep into the theory there. I just want to cover the overview of the algorithms so you know what the options are available there. Now let's talk about stochastic gradient descent. In order to talk about that specific algorithm, I just want to provide a quick overview of gradient descent types of algorithms. Gradient descent is a generic optimization algorithm. It is capable of finding optimal solutions to a wide range of problems. The general idea is to tweak parameters iteratively in order to minimize the cost function. There are three main types of gradient descent algorithms. It's batch gradient descent, stochastic gradient descent, and mini batch gradient descent. And now I want to move directly to stochastic gradient descent option so we can talk a little more about that specific type. So the word stochastic means a system or process linked with a random probability. So that means in stochastic gradient descent, a few samples are selected randomly instead of the whole data set for each iteration. In gradient descent, there is a term called batch, which denotes the total number of samples from a data set that is used for calculating the gradient for each iteration. Suppose you have a million samples in your data set. So if you use a typical gradient descent optimization technique, you will have to use all of the 1 million samples for completing one iteration while performing the gradient descent. And it has to be done for every iteration as it becomes computationally very expensive to perform. This problem is solved by stochastic gradient descent. Sometimes stochastic gradient descent for short is called SGD. So that algorithm uses only a single sample, for example, just a batch size of 1 to perform each iteration. I do recommend you again to go and search online videos and articles about that specific algorithm so you can see the formula and how you can actually use that specific algorithm. Now, I want to talk specifically about some advantages and disadvantages. The only advantage is the ease of implementation and efficiency. There is a major setback with that stochastic gradient descent algorithm. That algorithm requires a number of hyperparameters and it is sensitive to feature scaling. Be mindful about that when you decide which algorithm you want to use for your classification needs. There are a couple of use cases that are perfect for stochastic gradient descent algorithm. One of them is Internet of Things, and the second one is updating the parameters such as weights in neural networks or coefficients in linear regressions. The fourth algorithm I want to cover today is k-nearest neighbors, or sometimes that algorithm is called KNN. So k-nearest neighbors is a pattern recognition algorithm that uses training dataset to find the k closest relatives in future examples. When k nearest neighbors is used in classification, you calculate to place data within the category of its nearest neighbor. If k equals 1, then it would be placed in the class nearest to 1. K is classified by a plurality pool of its neighbors. And as always, I want to talk about advantages and disadvantages of that algorithm. KNN algorithm is quite simple in its implementation and is robust to noisy training data. Even if training data is large, it is quite efficient there. The only disadvantage with the KNN algorithm is that there is no need to determine the value of K, and computation cost is pretty high compared to other algorithms. And now I want to mention some use cases that are perfect for that algorithm. For example, handwriting detection application, image recognition, and video recognition. Those are not the only use cases that you can use that algorithm for, but those are the most popular ones. Now let's move to the second set of algorithms. In that batch of algorithms, I want to start with decision tree algorithm. The decision tree algorithm builds the classification model in the form of a tree structure. It uses the if-then rules, which are equally exhaustive and mutually exclusive in classification. The process goes on with breaking down the data into smaller structures and eventually associating it with an incremental decision tree. The final structure looks like a tree with nodes and leaves. The rules are learned one by one, just one at a time. Each time a rule is learned, the tuples covering the rules are removed. The process continues on the training set until the termination point is met. A decision tree gives an advantage of simplicity to understand and visualize. Because of that, it is really easy to see if the model that is using that algorithm acting responsibly. One of the rules of responsible AI is transparency. So if the model is easy to understand, that means it's transparent. The disadvantage that follows with the decision tree is that it can create complex trees that may bot categories efficiently. They can be quite unstable because even a simplistic change in the data can hinder the whole structure of the decision tree. And now let's talk about the use cases that are perfect for that algorithm type. For example, data exploration, pattern recognition, and opinion pricing in finances. The next algorithm here is random decision tree or random forest. It can be performed for classification, regression, and other types of tasks. It operates by constructing a multitude of decision trees at training time and outputs the class, that is, the mode of the classes or classification or mean prediction or regression. A random forest as a meta estimator that fits a number of trees on various subsamples of data sets and then uses an average to improve the accuracy of the model's predictive nature. The subsample size is always the same, but the samples are often drawn with replacements. There are a couple of advantages and disadvantages there. The advantage of the random forest is that it's more accurate than the decision tree due to the reduction of the overfitting. The only disadvantage with the random forest classifiers is that it is quite complex in implementation and gets pretty slow in real time prediction. There are several use cases. That algorithm is really good at performance scores, predicting social media share scores, and also for predicting the failure of mechanical parts in automobile engines. Second to our last algorithm I want to cover today is neural networks. And it's not just one algorithm. There are so many different types of neural networks that you can use for all kinds of tasks, including classification. A neural network consists of neurons that are arranged in layers. They take some input vector and convert it into an output. The process involves each neuron taking input and implying a function, which is often a nonlinear function to it, and then passes the output to the next layer. Although layers don't really know about each other, weights are applied to the signals passing from one layer to the other, and these are the weights that are turned in the training phase. Weights are applied to the signals passing from one layer to the other, and these are the weights that are tuned in the training phase to adapt the neural network for any problem statement. There are some advantages and disadvantages of neural networks. It has high tolerance to noisy data and able to classify and train patterns. It performs better with continuous valid inputs and outputs. The disadvantage there with artificial neural networks is that it has poor interpretation compared to other models. In some articles that I read online, the most recommended neural network for classification is convolutional neural network or CNN. They are the most widely used neural network models for image classification. There are a couple of use cases that I want to mention for neural networks. Handwriting analysis, colorization of black and white images, computer vision processes, and captioning photos based on facial features or facial recognition. And the last algorithm I want to cover today is support vector machine. The support vector machine is a classifier that represents the training data as points in space, separated into categories by a gap as wide as possible. New points are then added to space by predicting which category they fall into and which space they will belong to. There are some advantages and disadvantages there. This algorithm uses a subset of training points in the decision function, which makes it memory efficient and is highly effective in high dimensional spaces. The only disadvantage with the support vector machine is that the algorithm does not directly provide probability estimates. There are also a couple of use cases that I want to mention that are perfect for that kind of algorithms. Business application for comparing the performance of a stock over a period of time, investment suggestions, and classification of applications requiring accuracy and efficiency. So now when we're done with the algorithms, I want to move forward and talk about steps for machine learning training. Those steps for machine learning training can be used for classification, regression, or any kinds of machine learning tasks. Here's the whole process. First step here is data preparation. It is very important and I can't stress it enough. Data preparation is maybe the most important part of the whole machine learning training. In order to prepare data, you need to make sure that it's clean, it is up to date, and then you need to try to remove all biases that are there. You need to remove all missing data. In some cases, you need to remove some stop words like A is the, and sometimes you just need to convert some text values into numerical values for training purposes. When you are implementing responsible AI principles, they're not only valid for models themselves, but also for data that you're going to use for your model training. Be careful what kind of data you are feeding to your model. If the data is not clean, if it contains some information that you are not sure about, maybe it was taken from a random place, be careful about it. Clean it out and make sure that your data is accurate and it's suitable for machine learning training purposes. Next step is to train your model. You are training your model using different algorithms. Some of those algorithms I mentioned before, but there are lots of other algorithms that you can use. There are also options of using AutoML for your training purposes. AutoML is not specific to any particular companies. Microsoft has their own tools for AutoML. Google has their own tools. AutoML is a wide concept that is used in different tools. AutoML actually saves some time and it will go through different models and different algorithms to actually pick the best algorithm for your data, and then it will train your data using that algorithm. If you don't have enough experience, or maybe you just don't have enough time to go through several algorithms to pick the best, AutoML is a good option for you. It saves lots of time and it is very fast, and usually it's really efficient. Next step here is evaluation. Once you train your model, you need to evaluate it and make sure that it performs well. Usually, it's as simple as just feeding testing data and seeing the output. If accuracy is high, that is good. In order to evaluate your model, real data scientists and data engineers usually use all data and then they separate it before training, use some of it for training purposes and some of it for evaluation purposes. That way, you are making sure that the data that you're using for evaluation wasn't being used for training and it's new data for your model. If your evaluation is successful, you can move to next step and deploy your model. There is the whole ML ops concept, which I'm not gonna touch today, otherwise that video will be way too long. If you are a developer, you probably know about DevOps. ML ops, it's similar concept for machine learning. And now let's move to the demo. I'm gonna show you Microsoft Azure Machine Learning Studio, and we'll see how we can perform classification inside Azure Machine Learning Studio and what tools we can use to actually help us to be efficient and create really good models there. Here you can see the main screen of Azure Machine Learning Studio. Once you go to ml.azure.com, you'll be prompted to connect to your Azure subscription. Yes, you do need your Azure subscription in order to use Azure Machine Learning Studio, so don't forget about that. And then once you connected, you'll start acquiring some cost. So be mindful about that. Maybe not all, but most of machine learning experiments that you can do and data points that you create there, some jobs, they are relatively expensive, especially if you're just trying to experiment. So I do recommend removing your workspaces that are not in use anymore. I have a couple of workspaces currently that are in use for me. So you see the recent workspaces, and I have more of those available. If that's the first time you are logging in to the Azure Machine Learning Studio, you can check some documentation that helps you to kind of walk around and better understand what is happening inside that portal. You'll have an option to connect to tutorials and then see some additional resources. So even if that's your first time, you're not going to be left completely alone and just wandering around that portal. You have everything for success and lots of documentation, lots of useful information that you can use for your machine learning needs. So let me pick one of my workspaces where I already created setup for our classification needs. Once we go inside the workspace, we see some important shortcuts. There is an option to add compute. Without compute, you won't be able to run any kind of jobs. You won't be able to run notebooks or automated ML. So it's very important to create a compute. If you have your custom data, if you know what you're doing and you're not just experimenting there, or you just want to use your custom data for all your experiments, then you need to actually upload your data to Azure Machine Learning Studio and then connect that data to your machine learning pipeline. Then you can create a job to train your model. After your model is trained and evaluated, then you can actually use MLOps and you can deploy your model right from the portal. You can deploy it to Azure, for example. Then you see some recently viewed files right here. And then once you create your compute instances, they're going to be displayed here. So you see what is running, what is not running. I do recommend either deleting compute instances that you are not using or just turning them off if they're not actively being used. The best option is to actually create your experiment, run whatever you need to run there, maybe the whole pipeline, see the deployments, and then everything that is not being used can be deleted. Especially compute instances, when they're running, they're very expensive, so be mindful about that. And then even inside your workspace, you have all those links to videos and tutorials, um, which is really nice. So I want to provide you an option to start with Designer or start with notebooks, whatever you prefer. But before we move to a specific classification task, I also want to mention automated ML. I mentioned automated ML when we were talking about different algorithms. And also, you heard that AutoML can save you lots of time and perform really well for all kinds of tasks, including classification. So here, if you want to create a new automated ML job, you can do it inside Azure Machine Learning Studio. I don't have any AutoML jobs in that workspace specifically. I'm not gonna cover that option today. I want to focus on the designer option and notebooks option. So let's go to the designer. And here you have classic pre-built pipelines. Here, there are lots of them available. You can create a new pipeline using classic pre-built component. You can also create a custom pipeline. I already have pipelines created. And those pipelines are for diabetes research, for classification there. So before we go to the pipeline, let's go to the data, and then that's the data that I currently have here. I have that diabetes data set that I downloaded and then uploaded it to the portal. You can upload it by clicking create, and then for evaluation purposes, I hope you remember that you need to actually separate your training data from your evaluation data. But before you do that, you just need to upload the whole data set here. And then if you're using Designer, for example, you can use some components there for separating your data. If you're using notebooks and you're writing code, there are also options to actually split your data. So I do recommend to start with just uploading the whole data set here. And let's go back to the designer and go to that pipeline. So we have pipeline drafts and pipeline jobs. You see that I ran a bunch of them a couple of times. So let's go to the diabetes classification. When you are creating your initial pipeline, that area is gonna be empty, so you will be able to drag and drop your components there. I already have the whole pipeline set up. I already use that for training and creating models. But if you started from scratch, you have options to connect to your data, and you see those are data sets that I have, and also some pre-built components that you can use. You can also write your custom components, and then they will appear here. You also have options to use sample data for your experiments if you're just trying to better understand how those pipelines are working. You don't have to go out there and search for data. All the sample data sets that are available here, they're pretty clean, so you don't need to worry about that. You don't need to specifically clean them, but if you are getting data from somewhere else, be mindful and make sure that the data is clean and ready for machine learning training. So let me actually close that section here and then go through the components that I have. I'm gonna close um, I'm gonna close that part here and then move it a little here. So that is the diabetes data set. That is my custom data that I have. And that's the data that I'm gonna use for my experiments. Um, First, the data set wasn't really clean, so I can also use the pipeline to clean the data first and then make sure that it's ready for machine learning purposes. So I got the data, then I'm using data normalization. So here you can go through the categories and just manually search for the components that you might need. Or if you know the name of the component, you just type it here. And that's pre-built component that you have, normalized data. It rescales numeric data to contain dataset values to standard range. And you see all the information about that specific component. And then you can click Use Component, or you can just drag and drop it there. Make sure that you are connecting your dataset to the normalizer. Then you can actually split your data right here using the designer. So you don't have to manually go to your data set and create maybe split it into separate data sets for training and evaluation. You can do it automatically here using one of the components, and that component is split data. Once you split the data, you use part of it for training purposes and part of it for evaluation. So if we go back to the parameters here, we see um, that we split it 70-30. You see it here, split in mode, split in rows. You can also split columns if you have data set that is in columns. In order to modify those parameters, you just need to double click on that split data or any other component if you want to change the parameters there. Double click and then you see that section where you can change the splitting mode. You can change the splitting there. We used again 70% here. And change the output settings, some run settings. There are lots of options for customization there. Kind of close it for now and go back to the pipeline. For that model, I am going to use two-class logistic regression. There are also other algorithms available. Since that's not an AutoML option here, I just pick the algorithm myself. It doesn't have to be that one. And then we are connecting to that train model component. We're connecting the algorithm itself and then the data that we need to use for training purposes. Once we train the model here, we need to score it. So before we go to the scoring option, I'm gonna open what is going on inside the training component here. So I added model explanations here. I set it to true. I'm gonna close that. And then after the model is trained, we need to score it. So we are connecting part of the data set that was separated for evaluation purposes and with the trained model output. So inside here, we don't have that many options that we can tweak. I'm gonna close that. And so after that, we are evaluating that scored model. And then we can use those evaluation results. We can output them somewhere. We can maybe store them or upload to Power BI. You just name it. Or you don't have to use them anywhere. You can just evaluate the model and then just see what is the result of that evaluation. And that's it. Decide just for yourself what to do with that information. Once you're done with your pipeline, once you're done building it, you can submit your pipeline and create a job and then run the job, get the output and see what you get from that training and maybe tweak something, change something. I'm gonna go back here to designer pipeline jobs that I ran. You see that diabetes classification. I have it here. I ran it and it took 6 minutes 50 seconds to run. I can go to inside the job that I ran and see what's going on here. There's a pop-up. So once you run the model and you get results, you can right click here. You have option to preview your data, evaluation results. You can access data. You can register your data. Let's actually, you can also view logs, which is very important. Preview data, evaluation results here, and you see precision recall, lift curve, all the important information, and you can actually change the threshold here and see um, how the numbers are changing. And some scores here for each data input there. So really interesting to see, really useful for evaluation purposes. I'm gonna close that. You can also see the data set. So in actually that job, that pipeline, and then eventually that job, we are predicting if person is diabetic or non-diabetic. And you see that we have zeros for non-diabetic case and one for diabetic case. So that's the goal of our pipeline and our model. So I'll go back to the designer. In order to create an inference pipeline that we can later reuse and deploy and actually use the results to output it somewhere on the web, maybe use as a REST service later on. What we need to do, we need to go back to the jobs, go back to training, since we have already completed jobs. And then here we have option to create an inference pipeline. We have real-time inference pipeline option and batch inference pipeline option. We're going to choose real-time inference pipeline. In order to save some time, I'm going to go back and show you the real-time inference that I have here. So it is pretty much the same. With the help of the Azure ML Studio, I reused most of the pipeline that I created before. I just replaced the inputs here. So we have web service input. We can enter data manually. And also we have that data set for which is already transformed and normalized. We don't have to use that one, but it is possible that we want to use it as well. So we'll use the apply transformation component here to transform the inputs, and then we'll do the scoring, and then we'll execute Python script here. Let me open that. That's the Python script. And let me extend it a little bit so we see. We use pandas here in order to actually return scored results in readable way that our web service can actually use and can return. And that's going to be more useful than just random percentage or random numbers that scoring returns. And then we have the web service output here. Then we can use that inference pipeline in first we need to deploy it, and then we can use it in REST API. So we'll provide the input, and then it will go through the model, and model will actually um, uh, the model will actually provide the results, and web service will return those results. So I'm not gonna go through the job output of that pipeline. I'm gonna tell you how you can, what you need to pay attention to when you are training your models and you are submitting your pipelines and checking if they're working or not. In order to run the pipeline, you can click submit and then you can either select existing experiment or create a new one. It's very important to actually have compute target and I have my default one set up here. And in order to create your compute, you need to create it here. You have option to create compute instance and then compute clusters here and inference clusters. Make sure that if you're not using your compute options that you are deleting them or at least you are stopping them. So we're way over time. So I'm gonna just quickly mention the option to use Jupyter notebooks here. And here I have data, my data set for training. And I used Python here to write very simple code to predict um, whether it's a toxic comment or non-toxic comment. So I'm basically getting that trained CSV file. I can open it so you see the data that I'm using. That's the data. And then I am predicting that column, whether it's toxic or non-toxic. So I'm going to go back here. And then I used scikit-learn. If I use MLflow with scikit-learn flavor, then I can also use Responsible AI dashboard. I have a lot of videos, and there are not only my videos related to Responsible AI. Um, I do recommend to check it out. Responsible AI is also available right inside Azure Machine Learning Studio, so definitely check it out. And so in order to actually run Jupyter Notebook, you also need to connect it to your compute. I am connecting to the same compute instance and then make sure that it's running. And then you can actually run the code inside Jupyter Notebook. And then once you get your model, then you can save it in models here, for example. I didn't save it. And I didn't save the model that I created inside the pipeline. But if you want to save the model here in order to reuse it somewhere else, then that's an option too. And then you'll have all your models here. And that's pretty much it about Azure Machine Learning Studio and how you can use it for classification. I know I went over it very fast. So if you have any questions later, feel free to reach out to me. Thank you so much for joining me today. I hope you learned a lot about classification and Azure Machine Learning Studio. If you have any questions, feel free to reach out to me through Twitter and LinkedIn. And I'm wishing you happy holidays. And I hope you will also enjoy other sessions at Festive Tech Calendar. Thank you so much. Goodbye.